As this is an Ireland-Wales conference and I am from Ireland representing, I think it's appropriate to give a welcome in Irish, Oscailga. Díomh cóide agus fáilte roimh go léir chuig an códal Ecostructure inniu. Hello friends, you are all very welcome to the Ecostructure conference today. First of all, I would just like to apologise. Unfortunately, I was supposed to be there in person, but I am a product of the rail strike, and I was unable to travel yesterday, so apologies for not being there today. I'm sorry not to be there. But thank you for the opportunity to give this keynote. So put very simply, humanity needs biodiversity. We need a range of different species to support all of the various different ecosystem services that we value as humanity. We need climate regulation, we need food, we need raw materials, we need organisms to clean the water. All of these are really, really valuable services that are essential to humanity and into the future. Unfortunately, due to the artificialization of the global ocean and the global coastline, we are seeing biodiversity being eroded in our oceans and seas and coastlines. This is a recent figure showing you the sort of global scale of the artificialization in coastal and offshore environments. And it's showing you the physical footprint of marine construction globally. What this looks like on the ground, this can be a range of different types of structures. So in coastal environments, you have things like seawalls here in the centre, you have groins and breakwaters in the top left. In the subtidal environment, we have lots of undersea pipelines and all sorts of other structures. And we also have many offshore structures, including wind farms and oil platforms as well. There's a huge diversity of structures that are being put into our marine environment, and the number is going to increase in the future. Of course, any artificial structure that you place in the marine environment will become colonized by marine life, whether you like it or not. Sometimes those species are desirable, but very often these are non-desirable species, often encompassing invasive species, which I know is a critical question of the Ecostructure project. Thankfully, moving forward, understanding that marine life will colonize these structures, we are now looking to build these structures, not just with a primary function with humans in mind, but we are thinking about beyond humans, we're thinking about the natural environment, and we are now designing what we refer to as multifunctional structures, and they will have many functions beyond our human needs. This is all part of the mitigation hierarchy. So the people who work for government and agencies in the room will very much understand the mitigation hierarchy. But this is basically trying to balance development and nature through mitigation and compensation. And this is where eco-engineering really comes into its own. Eco-engineering is the design of sustainable ecosystems that can integrate human society with its natural environment for the benefit of both. And this, in the context of artificial structures, we can often refer to it as greening the grey. This is a concept that we're very familiar with on land. Things like living walls are very important. Hives, all sorts of things are appearing in terrestrial environments. We're a little bit lagging behind in the marine environment, but we're very quickly catching up thanks to projects like Ecostructure, which are very quickly advancing this field. So I started working in this field back in 2009, and I can honestly say there were two papers that were key papers that I would put under engineers' noses and say, hey, look, this is a good idea. You know, there's lots of things that we can do to design artificial structures. I'm now at a place where I can't even keep up with the literature. There is so much happening in this field, and it's a very exciting, and I think you're getting the sense it's a very important field to be working in. And we're now at a place where there are lots of different tools out there and lots of different techniques that people have trialed to enhance the biodiversity on these artificial structures. So we've already mentioned that many of these experiments in the past have been at a smaller scale, but just to showcase you what these small scale techniques can look like. For instance, lots of people are working with the texture and composition of the materials themselves. Concrete, of course, is one of the most prevalent materials in the marine environment. There are all sorts of manipulations and techniques that you can apply to concrete to make it better for marine life. We can also incorporate pits and crevices into materials like concrete, for instance, and you can also retrofit pits and crevices and nooks and crannies onto existing artificial structures as well. Marine life doesn't like to be sitting out, exposed to sunlight and temperature changes. It likes to hide in amongst pits and crevices and be shaded from environmental damage. So these kinds of small-scale interventions can be very, very effective at the scale of the organism. Lots of great work, including Ecostructure, has advanced the field in creating artificial rock pools in intertidal environments where the tide comes in and the tide comes out. Of course, organisms, when the tide is out, are very stressed. Artificial rock pools can create more benign environments to enable species to persist on these artificial structures where they might not normally be able to thrive. Just like on land, where we garden desirable species, we're also now in a place where we're beginning to trial transplanting organisms directly onto artificial structures. And these organisms may be desirable for a range of different functions, from habitat provision, food provision for other organisms, or conservation purposes, just like we do on land. We're now at a place where the experimental scale research is now informing actual practice, and we're really at a place where we're starting to scale up the science. As I said, I've been working in this field since 2009. We initiated the bioblock here on the left-hand side, as you can see here. This was a prototype. There was only one, but I'm very pleased to say that experiments like this, that were quite groundbreaking at the time, are now informing the design of real-scale products that are being designed by many companies all over the world that are really scaling this up to practice. Examples include Econcrete Tech, a company based in Tel Aviv. An example here is a large-scale panel. We're no longer designing marina and quay walls to be flat, which are poor for marine life. You can see this panel here has lots of rugosity and habitats that are very important for marine life. Companies such as Art Marine, which I have done a lot of work with, you can see here that there are modular units here. Each of these is an actual single unit, but they can be attached to each other to scale up these units to have wider benefits in an ecosystem. So it's a great place to be. The science is there, and the science is informing the practice at real scale. There are not that many very large-scale examples of this kind of research happening, but I'm pleased to say that there are at least two that are really working at much broader scales than one individual structure. One example here, the image you're looking at here is the living seawall in Sydney. The units here were designed by Reef Design Lab, but researchers at various institutes in Sydney have been conducting this research. The image here is just showing you ecological enhancement of the seawall, but this is part of a much wider scale project that has many other habitat types, subtidally, intertidally, and on land as well. So this is very much happening at the landscape and seascape scales. Other examples of real scale examples, this is Elliott Bay in Seattle on the west coast of the United States. And you can see here, this is on the bottom here, this is a seawall here underneath. The seawall has been affixed with many different panels of biomimicry. Each of these are actually mimicking mussels and anemones, for instance. There's overhangs here creating shading. You can see there's light penetrating panels on the top here. Previously, no light would have come through, so things like kelp, sea grasses, for instance, wouldn't be able to thrive in this environment. And again, this is what you're looking at is a small scale example here, but this again is part of a much wider scale project involving subtidal environments, fish enhancement, and terrestrial enhancements as well. So again, the science is very much scaling up to real scale landscape and seascape examples. We're also in a position where people have been collating all of the information available. I've been very fortunate to work with a lot of people who have been collating this information. And there are lots of great reviews that are now out there. Just 3 are here on the screen. So the science is being pulled together and produced to make it more accessible to people in review format. The science is also reaching the public as well. I can't count the number of links that I see now and emails that I get with all sorts of ways of communicating the science to the general public. The example here is from Hackeye magazine, which is a really beautiful magazine that communicates science to the general public. And this one here, the image is showcasing the Seattle example of the seawalls there. You can see with salmon here in the foreground. The living seawalls, of course, are getting great traction from Sydney. Here's an example from Reuters showcasing Mariana Meyer Pinto and the living seawalls in Sydney. And there are other more local examples here. This is a New Zealand example showing you an example of these eco-enhancements placed on a rock armour. So this is all great stuff. We're now in a position where the science is happening, we're scaling up, there are reviews available, it's reaching the public. It is great, but there are some buts here. There are still many limitations. The vast majority of the research to date has been rather small scale and short term. There has been a general focus really on coastal environments. It's much more expensive and it's much harder to work on offshore structures. So the vast majority of the literature to date really has been focused in coastal environments. We tend to use simple metrics. Quite a lot of the time we measure simple things like numbers of species and sizes and things like that. We need to be doing more than that, and we need to be looking beyond these simple metrics. Up until now, the vast majority of the research has, of course, been carried out by the scientific community, by researchers like myself included. And as a result, we tend to produce our research and make it, we publish it in scientific journals, which is often very inaccessible to the people who are actually going to be using this science in the real world. From a practice perspective, we've had feedback from practitioners that there has been a general lack of evidence base. A lot of the research is in disparate journals, and it's very hard to sort of pull together what sort of interventions might work under different environmental conditions. There's also a big concern that greenwashing may be going on, where eco-engineering might be used for harm to enable coastal developments to go ahead. And in many parts of the world, we're lacking the necessary policy drivers to enable this kind of research and practice to happen at real scale. I'm happy to say that Ecostructure has gone a very long way in addressing a lot of these concerns. I'm not going to steal their thunder and tell you exactly what they've done to do this. That's what today is about, and they're going to show you how they've filled many of these limitations and knowledge gaps. I'm very proud to have been a part of this project, because it's been really wonderful to hear from in the past me talking about the limitations to actually seeing it being addressed by this wonderful project. So looking to the future, there are some major concerns ahead. We've already talked a lot about climate change and with the previous speakers before me. We're also looking to a future with many more people on Earth. And as a result of that, we're seeing a lot more coastal development. The image here is just showing you an example of an artificial island that's being built in Penang, in Malaysia, where I do a lot of work. This is one example of many. This is on the increase. We are seeing really, really large-scale developments happening as we speak all over the world. Rather than burying our heads in the sand and saying this is hard, these structures are too big, we have to face this head on. In the time that I've been speaking to you, about 3,000 people have been added to the Earth. By the end of the conference today, about 80,000 people will have been added to the Earth. This is a real problem. We have to face this. We have to look to the future with hope. Projects like Ecostructure are enabling us to do that. We must work together. We must think beyond ecology. We must work with the engineers, the landscape designers, artists, and we must think big and work together to enable sustainable development into the future. I'd like to thank you all. Jialach Garavmaha Galore. Thanks to many people who've been involved in the Ecostructure project and my own research as well. Just many collaborators named here, to name a few. But just I wanted to wish you all the best with the conference today. It's been a really wonderful project, and I look forward to hearing how you've advanced the field in a major way, which I know you have. Thank you.